In this problem, a farmer plants X units of wheat in her field. She can't plant any more than 100 units. The yield will be 10x minus 1/10 x squared. It costs the farmers $100 for each unit of wheat she plants, and she's able to sell each unit she harvests for $50. So how much should she plant to maximize profit? So what do we have? We've got that, right? We've got a constraint here. 0 is between, or x is between 0 and 100. Here's our yield. So for every unit of wheat she plants, she'll be able to produce this much wheat. It costs $100 for each unit she plants. So to plant wheat, it costs $100. So the farm equipment and water and all that, fertilizer, and when she takes it to market, she could sell it for $50 a unit. So let's put down our facts. So a constraint we already have. We know one constraint is that 0 is less than or equal to x less than or equal to 100. We know some facts that we know, that the yield is 10x minus 1/10 x squared. We know that it costs, cost is, well, it's $100 for each unit. We should maybe say what x is, even though it's in the problem. We just say x is units of wheat planted. Then, and it costs $100 for each unit planted. So that means our cost is 100x. That's how much it costs. And then her return on her investment is $50 times whatever is produced. So our return, or our, we'll just call it return, kind of a return on investment, will be $50 times the yield. And we have the equation up there, so that's $50 times 10x minus 1/10 x squared. Okay, so these are still just kind of the facts we've put together. The cost is that, the return is that, and she wants to maximize profit. So we want to maximize profit. And what is her profit? Well, her profit will be whatever her return is minus the cost. Right? Whatever she gets back from when she sells her wheat minus whatever it cost her to make the wheat. So her profit, we'll call it P of x, since that's really the only variable. P of x is equal to return. And I'm going to go ahead and multiply this 50 through. So this is 500 minus 5x squared. Right? That's our return. And then the cost is 100x. So this is the farmer's profit. Whoops, there's an x here. Forgot. I was going to say, whoa, something's weird. Combining this is equal to 400x minus 5x squared. Okay, so that's the profit function. That's the function we want to maximize, and it's in one variable. So the only constraint we have is our boundary, which means since we've got boundary points, we have critical values at the boundary points. So critical values will be 0 and 100. And we can see, well, she doesn't plant any wheat, she's not going to make any money. So that would be a minimum. So we need to find some interior critical points. So that's when the derivative is 0. So we need to set 0 equal to the derivative of profit. And profit's this function, so the derivative is 400 minus 10x. And that equals 0, well, exactly when x is 40. So we'll add that to our critical values, and that's all of them. So we got 0, 100, and 40. And now let's, since we've got 3 critical values, we don't have to use a second derivative test. We can just evaluate at all the endpoints and the interior critical values. So we'll put our C here, our profit function here, and we need to look at 0, 100, and 40. So as we already talked about, if we put 0 into our profit function, we'll get $0 back. If she plants the total amount of wheat, so she plants 100 units of wheat, if we put this into here, we'll get negative 1,000. So if she plants as much as she can, she'll lose $1,000. So this is actually our minimum. That'd be a bad scenario. And then if she plants 40 units of crop, she'll make a profit of $8,000. So there's our max, right? This is our max. For our profit function, this is max. And this is min. And so writing down the solution, we have that the farmer should plant 40 units of wheat to maximize profit.